Hey guys, hoping all is well with everyone. So in this video, we're going to be looking at our question of the day, which revolves around Calculus 1 level mathematics material. So the question states, what is the slope at x equals 0 of the following function, given f of x is equal to sine of x squared plus 2x minus 3? Now, I'm going to just grab the bull by the horns here and address the big issue with this problem, and it's literally just the way that is worded. It is very misleading in the fact that it looks like a very simple evaluation problem. A student will see a question like this and they will evaluate sine of x squared plus 2x minus 3 for 0, and they're going to get an answer that is likely one of the choices in the answer pool if this is a final examination or a standardized test even. Unfortunately, that is incorrect. And the reason that it's incorrect is for us to be able to determine the slope at x equals 0, we have to evaluate x equals 0 at the instantaneous rate of change of sine of x squared plus 2x minus 3, which means that we have to be able to evaluate x equals 0 at the function's derivative. Now, what that also means for us is that we're going to be having to use the application of the chain rule along with other differentiation techniques. I understand that the chain rule can be a little daunting, but we're going to break things down step by step, and I'm going to show you guys a nice way to keep everything clean and organized, so it's much easier to be able to approach the chain rule as opposed to trying to memorize the formula. And you're also going to see ways that are good habits to get into as you learn more and more differentiation techniques. So let's start things off with step number 1, which is going to be determining the derivative of the function sine of x squared plus 2x minus 3. And I'm just going to use the caret as the exponent indicator while I'm typing. Okay, so determine the derivative of the function f of x is equal to sine of x squared plus 2x minus 3. So as I mentioned, when it comes to these, don't always feel like you have to memorize the formula. Some professors will say like memorize the chant. So just a little bit of differentiation rules. So d dx of f of g of x is equal to f prime of g of x times g prime of x. So the chant that some of you may be familiar with is take the derivative of the outside, keep the inside, and multiply it by the derivative of the original inside. But another way that you can approach this is by letting this be two different functions, f and g, just like the formula. But we can make a table here to have the functions and their associated derivatives. So if I set this as, if I set sine of x squared plus 2x minus 3 as two functions where f of x is going to be equal to the sine of x, then I can determine its derivative, and the derivative of sine of x is going to be cosine of x. And this table approach is really good for keeping things organized and helping you kind of understand the relationships between your functions that you have in your question and the associated derivatives that you may be evaluating at. So this will be cosine of x. And then for my g of x, this is going to be the polynomial x squared plus 2x minus 3. Now, with this polynomial, with determining its derivative, we just have a couple of things going on. The biggest thing we have is just power rule, but you also have the application of sum and difference rule. So you have the approach that you can take this polynomial and each of these terms is its own individual function that you can take its derivative at. But for this, we'll mostly be approaching it via power rule. So g prime of x, and then I'll go ahead and I'll put the power rule down here. So let me go ahead and power rule. So the power rule states that d dx, always remember your differentials, guys. They're very important, especially for keeping things organized, of x to the n is going to be equal to taking the original exponent as its new coefficient. So we have n times x, and then it's going to be n minus 1. So applying that, for x squared, you have bringing the original exponent as a coefficient, keeping the variable, and then it's going to be 1 less than the original exponent. So this will just be 2x to the 1. We can do the same thing with the next terms. This will be 2x plus, so you have the coefficient of 2, and then you have x to the original first power, so you can bring that down if you wanted to as a placeholder. And then you have x to the 1 minus 1, which will be x to the 0. And then the derivative of a constant is just 0. Okay? So your simplified derivative for g of x is just going to be 2x plus 2. Okay, so there's a couple of differentiation rules happening, with that being the power rule, and then the sum and difference rule also being applied in the polynomial expression. So now that we've determined all of the parts of our function as well as its associated derivatives, now it's much easier to define the derivative. So we can go ahead and even make that a step if you wanted to. So you can say step 2, rewrite the simplified derivative. Okay. So again, now you have your model, and now you have, again, the chant if you wanted to. So the derivative is going to be cosine, so derivative of the outside, keep the original inside, times the derivative of the original inside, which will be 2x plus 2. Awesome. And as you guys can see, that allowed us to stay very organized, but it also allows us to be able to keep track of everything in a very organized way in case we have to refer back to it. One of the reasons I want to draw your attention to this is it's a good habit in the fact that going forward you're going to be learning a differentiation technique known as integration by parts. You learn it more in calculus 2, but what it is in the formula itself you are using both the original function and its derivatives in the same function, in the same formula. So being able to keep track and be very comfortable with going from function to derivative is really important. But again, this is a nice habit to get into. So step number 3 is to evaluate the derivative for 0 to determine this, Okay, So our whole goal behind this was to be able to determine the slope, which is the instantaneous rate of change at x equals 0 for this function. But in order to do so, we had to be able to do so at its derivative. So this is where the justice prevails. So we're going to take the cosine, and again, anytime you see the x variable, you'll substitute it in with a 0. So this will be 0 squared plus 2 times 0. And I really do recommend the substitution step, just to allow yourself to see everything that is occurring during this, because you're going to notice a lot of stuff cancels. Oops. Okay. And then this will simplify to the cosine 0 squared, for intents and purposes of this level of mathematics, is going to be 0. I know you guys are starting to get into calculus related things, and we start to soon realize that 0 to powers can be a little bit different, but for this it's going to be 0. And then we have 2 times 0 is 0, and then minus 3, and then multiplied by 2 times 0 is 0, plus 2. So step number 4 is just kind of a built on, actually I should say step 3b, determine the final value of the trigonometric function. So this is going to be the cosine of -3 times 2. And when you evaluate this using your calculator, your result is going to be an approximation of -1.98 after rounding, and that would be the possible choice in your answer pool. So as you guys can see, a lot of differentiation took place in this type of question, and a lot of differentiation techniques were used. But again, if you get organized in the very beginning, things are very clean, and again, it allows you to kind of keep track of everything that you need. And again, it's not about memorization, it's just finding the most comfortable way for you to remember the formula, whether it be a chant or just a natural flow of, you know, practicing and seeing how functions relate and have relationships with their derivatives. But I hope this helps you guys out. If you have any questions, please don't hesitate to reach out and message me. If you have any other ways that you can approach this, I would love to see them. I always like to see different ways that questions can be approached. But I hope to see you guys soon in our next question of the day. As always, thank you so much for watching. Please take good care and be safe.